Good morning and welcome back to the channel. Today our discussion is going to hinge on factoring and more specifically GCF factoring. And when we're talking about GCF factoring, we're talking about the greatest common factor. Now what factoring actually is, when we talk about factoring, it is actually talking about division, okay? So all we're taking here when we factor is we are looking to divide by this greatest common factor. So let's say we have the expression 6m plus 15 here. My first inkling here is to find what is the greatest common factor between 6m and 15. So the two questions I have to ask myself. Question one, do they both share a variable? Do they share the same variable in this case? So what I'm talking about is, do they both have the same variable m? If they already have the same variable m, I would be able to combine these as like terms, okay? So in this case, I don't have that. So I'm then looking for my next question, which is the coefficient. And the coefficient is just the number that precedes the variable, the number in front of the variable. So do I have a greatest common factor between the coefficients? Okay? So I don't share a variable here, but I do share a coefficient that has a greatest common factor. That's between 6 and 15. So between 6 and 15 right here, I have a greatest common factor of 3. So this is what I'm going to do from here. I'm going to divide both terms by 3. So I'm going to come up here and divide 6m by 3. And really, I'm just dividing the 6 by 3, which makes it 2m. I'm going to come to the 15 over here, and that's a positive 15. I'm going to divide the positive 15 by 3. That becomes a positive 5. Now, this is not an equation. If we were working with an equation and this was equal to something, we would divide both sides by that 3, and then because we divided it equally, that 3 would no longer be in our solution. However, here, what I always tell my students is this is like you're pulling this 3 out of both of these. So you're pulling them, I think about it like a stage, you're pulling them off stage. So that 3 that we had, that we pulled out, is actually going to drop in, and now it actually comes outside of my parenthesis. And the way we say this is 3 times the quantity, and then we say underneath 2m plus 5. And quantity implies that there are grouping symbols around it. Okay? Essentially what we have done here is we have created a reverse distributive property problem. How I can check my answer is then to literally come back and distribute that 3 into both terms. So mentally, I'm going to come through and say, all right, what's 3 times 2m? I get 6m. What's 3 times 5? I get 15. That confirms my solution at least makes sense when I pulled out that GCF. My second example. Now I have 42 minus 7m, or 7m, excuse me. I look again. Do I have a same variable? Do I have a like variable? I don't. Then I look for my GCF between 42 and negative 7. Okay? Here, my greatest common factor is actually going to be that negative 7. I want my variable to be positive here. I want that variable to be positive. So in that case, I'm going to divide both of them by that negative 7, by this coefficient. Okay? Now I divide them individually. 42 divided by negative 7 is negative 6. Your sign rule will still apply. And then negative 7 divided by negative 7 becomes a positive, and a positive 1n. You could, if you do write the 1 in, it's not the end of the world. Typically, though, I don't write the 1 in because it's understood that this n is a single n, 1n. That negative 7 as well comes outside my parenthesis here. And I would say it is negative 7 times the quantity of negative 6 plus n. Okay? Quick little distributive property to double check, and it will check out in that case. Finally, let's say I have an example like this. Now I ask myself, do I have a like variable? I do. They both contain a y, so I know my GCF, I'm going to be pulling out a y from both. And then I look at my terms here, negative 12 and negative 18, both share a greatest common factor of negative 6. I'm going to pull out that negative here because I want this lead term to be positive. Okay? So I'm going to divide both of these by negative 6y, and all that's going to do is literally bring out a y from both. Okay? We're not going to worry about exponents here. but we're essentially subtracting a y from each term. So when I come through, that's negative 6y will come outside my parenthesis. That was my factor, and now I'll divide. Do it in parts. Negative 12 divided by negative 6 is positive 2. And we said those y's are going to technically subtract themselves because they're coming outside of that parenthesis, and you're left with 2x. And I do it one more time over here. 18 divided by negative 6, that sign changes to a negative 3. And then y divided by y, because I pulled it out, is 1. So it just becomes negative 6y times the quantity of 2x minus 3.